In the producer-consumer problem, there is one producer and there is one consumer. The producer produces an item and the consumer consumes the item that is produced by the producer. While the producer and consumer shares the same memory buffer that is of fixed size. The job of the producer is to generate the data, put it into the buffer, and again start generating data. While the job of the consumer is to consume the data from the buffer. The problem here is the buffer provided is of fixed size. The producer should produce data only when the buffer is not full. If the buffer is full, then the producer should not be allowed to put any data into the buffer. Else, the consumer should consume data only when the buffer is not empty. If the buffer is empty, then the consumer should not be allowed to take any data from the buffer. We need to ensure that when a producer is placing an item in the buffer, then at the same time, consumer should not consume any item. In this problem, buffer is the critical section. The problem can be solved by using semaphore and mutex. Semaphore is an integer value that can be accessed only through two standard operations, that is, wait and signal. Semaphore is also known as a signaling mechanism, and a thread that is waiting on a semaphore can be signaled by another thread. Semaphore is of two types, binary semaphore and counting semaphore. Binary semaphore. Each value is initialized to 1. It can have only two values, 0 and 1. It is used to implement the solution of critical section problem with multiple processes. Counting semaphore. Its value can range over an unrestricted domain. It is used to control access to a resource that has multiple instances. Next is mutex. Mutex is a mutual exclusion object that synchronizes access to a resource. It is created with a unique name at the start of the program. The mutex is locking mechanism that makes sure only one thread can acquire the mutex at a time and enter the critical section. This thread only releases the mutex when it exits the critical section. Mutex is different than a semaphore as it is a locking mechanism, while a semaphore is a signaling mechanism. A binary semaphore can be used as a mutex, but a mutex can never be used as a semaphore.
Okay, so now I am Pinach Bay and now I am here to discuss the solution of the producer-consumer problem. The producer process, the code here given is the producer process, defines the producer process, or it is a solution for the producer process. The code here is a do-while loop code. In this code, the empty and the full are the two semaphore variables and the other variable is the mutex. The mutex is initialized to 1 and the empty is initialized to n, which is the maximum size of the buffer. Also, the full is initialized to 0. The mutex semaphore ensures mutual exclusion. The empty and full semaphores count the number of empty and full spaces in the buffer. So, in this code, our first job is to produce the item. Once the item is produced, the wait operation is carried out on empty. This indicates that the empty space in the buffer has decreased by 1. Then wait operation is carried out on mutex. so that consumer process cannot interfere. After the consumer process cannot interfere, we can see here that the wait operation is carried out on empty, and then the wait operation is carried out on mutex. Once this step is done, our next operation is that we should put the produced item inside the buffer or push the item into the buffer. Once the item is put in the buffer, signal operation is carried out on mutex and full. The signal operation carried out on mutex indicates that consumer process can now act, and the signal operation carried out on full shows that the buffer is full by 1. Here is the end of our producer process code. So we next discuss the solution for the consumer process. So the code here looks alike to the producer process code, but it's not the same. As in the consumer process, the first step is to remove the item from the buffer and then consume the item. Also, the buffer is full of the item. So now the wait operation is carried out first on full, which indicates that items in the buffer have decreased by 1. Then wait operation is carried out on mutex so that the producer process cannot interfere. We can see that the wait is done on full, and then the wait is carried out on mutex. Once these steps are complete, the item is now removed from the buffer, and once the item is removed from the buffer, the signal operation is carried out on mutex and then on empty. The signal operation carried out on mutex indicates that the producer process can now act again, and the signal operation carried out on empty shows that the empty space in the buffer has increased by 1. As you can see that the signal operation is carried out on mutex and the signal operation is carried out on empty. Once these steps are done, the item can be consumed by the consumer. So that's the end of the consumer process here. So finally we get the complete solution for the consumer or the producer consumer problem. Thank you.